I did this question a really complicated way, so I'm going to talk about that to be fair, but let's first of all look at the quick way of doing it. So the key thing is all about the fact that the visible black region is 7 times the area of the white circle. So let's say originally the black region is, let's just call it capital B. Now it's happy there. When we move it around, what is going to happen is we've still got the same area here as here, but the black area is going to be reduced by the area of the white circle. Now, because the black region is 7 times the area of the white circle, that means the white region is actually 1/7 times B. So if we reduce it, we're going to get 6 over 7B. And therefore the ratio of the areas before and after is going to be B to 6 over 7B. We can actually just cancel out the B's. 1 to 6 over 7 times through by 7, which gives 7 to 6. So here's how I did it, and it is more complicated. I've just been looking back over it, and it actually works in a similar sort of way. It's just a bit more disguised, less clear maybe. But anyway, here goes. So I decided to say that the largest circle has a radius of r3, the second largest r2, and then the smallest, the white circle, r1. So if I want to work out the black area before, then it's going to be r3 squared, pi r3 squared, to be honest, minus pi r2 squared. I ignored the pi because it's just a constant factor of pi throughout, but I'm going to keep it in here, I think. Um, Now, we're also told that that is 7 times the circle. So it's going to equal 7 times pi r1 squared. Okay, now I can cancel out the pi's. So r3 squared minus r2 squared is going to be 7 equals 7r1 squared. Um, okay, then afterwards, the area is going to be pi r3 squared, but then I'm going to be minusing pi r1 squared plus pi r2 squared because I'm adding the white and the grey together, minusing from the main circle. So remember, we're interested in the original black area um, ratio, which is going to be, I guess I should bring the pi's back in actually, pi r3 squared minus pi r2 squared to pi r3 squared minus pi r1 squared plus pi r2 squared. That is what we're interested in. So in both cases, actually, we can use this result here. I can divide through by pi, just like I did before. The left-hand side is going to become 7 r1 squared. And the right-hand side, well, I've also got r3 squared minus r2 squared. So I'm again going to get 7 r1 squared, but this time I need to minus r1 squared as well. See, actually, this is working in, this is what I mean by actually essentially being the same idea as this. I'm just kind of, to be honest, just making it much more complicated than I need to. In fact, when I did it, I made it even more complicated and I started completing the square on this sort of thing until I kind of, got stumbled to the answer eventually. Because I'm nearly there now. I can, um, yeah, I can just cancel out the R1 squareds and we've got our answer of 7 to 6. So, if you say to me oh, I just never would have thought of doing this here, and I'm not sure if I would have, then hey, it gets us there. It's a bit, bit unnecessary in the end of the day, but it is just using the concept of compound area, working through the information we're given, and it is just as valid.